So today I'm going to attempt to describe with an Australian perspective quite common hydraulic fittings. These are JIC to BSP adapters. JIC is quite commonly used in Australia. We adopted it from the Americans. BSP, common thread also, which we adopted from the British. What I have here is an array of adapters in JIC male nipple at one side with a BSP male nipple on the other side. What I also have is a hose tail, different size hose tails with female JIC threads. Ferrules designed to crimp onto hydraulic hose. Namely, these ferrules are designed to crimp onto 2-wire braided hydraulic hose. These are a match to our ENGMATTEC hydraulic hose here. Now our hose is got 2 layers of high tensile stainless steel braid. Now this is a 3/4 hose. There's actually 2 layers. There's 1 layer, and then under here is another layer. And the same with this 1/4-inch hose. There's another. That's the first layer. Under this layer, there's another layer. And if you look at the end, you may be able to see the 2 layers of braided hose in there. Yeah? Quite difficult to distinguish on the smaller 1/4-inch hose. But 3/4 ID hose, 1/4-inch ID hose. This hose also comes in 3/8, 2-wire, 1/2-inch 2-wire, 5/8 2-wire, and as mentioned before, 3/4 2-wire. Pressure ratings quickly. 1/4-inch 2-wire is rated to 5,800 psi working pressure. The 3/8 is 4,800 psi working pressure. The 1/2-inch is 4,000 psi working pressure. The 5/8 is 3,600 psi working pressure, and the 3/4 is 3,100 psi working pressure. The fittings, for example, we take a 3/8 hose with a 3/8 shell. You push them together like that. A 3/8 hose tail. The hose tail is designed to actually push into the hose. There's actually a shoulder there. If I pull this apart, you'll be able to see. There's a shoulder that actually this locks into. Alright? And this is what actually prevents the hose from blowing off at the elevated pressures that they can work at. So we actually crush this down to a certain diameter. And for 3/8, we actually crush this in a hydraulic hose press. We'll crush this down to 21.9 millimeters. So currently, it's at 26 millimeters, and we have a press that can generate up to 137 tons of force to squash this from this size down to that size. So that's a finished hose assembly. 3/8 2-wire hose, 3/8 2-wire ferrule or shell, and a 9/16 JIC female hose tail, which is started life as one of these, and one of these, and this hose. Alright, so that's a quick summary of hose and hose assemblies. So the most common sizes that we come across here in Australia are for 1/4-inch hose, 7/16 JIC thread, this is a 7/16 JIC female swivel. This is a 7/16 male. If you want to see what they look like cross section, if you have a look at this drawing, that's the male thread. 37-degree taper, and internally, if you look at the female, It's got an internal seat in there, which is that seat there. There's the nut. And when you actually screw these together, this seat squeezes into that, gets forced into that seat, and actually will hold up to very high pressures. These fittings are actually designed to be able to work up to 10,000 psi, but this hose assembly, it's the 3/4 hose, 3/4 2-wire, 3/4 ferrule, 3/4 2-wire hose, good for 3,100 psi working pressure. So it'll work all day, every day, up to that pressure with no problems at all. So moving along, we've got 7/16 JIC. If you want to identify what that thread is, it actually has 20 threads per inch. So if you get a thread gauge, I'm not sure if you can see that, but that's a thread gauge that actually says 20, so that's 20 threads per inch. And the diameter is actually measured on the OD. Now in Australia we don't have many verniers that actually measure in fractions, but it's close to about 11.5 millimeters. And if you were to convert that into inches, it's 435 thou. Moving along, the next most common size is 9/16 JIC. And this is generally designed for 3/8 hose fittings. Moving up from that is 3/4 JIC, again 3/4 on the outside diameter. And if you wanted to know what the thread pitch of that was, it should be 16 threads per inch. So if we were to get our thread pitch gauge, 16. Okay, so that matches. A 3/4 JIC female swivel hose tail designed for 1/2 inch hose. So this is designed to fit a 1/2 inch hose. Next size is not very common, but we find it on JCBs and on Bobcats. Is actually 5/8, yeah, which has 7/8 of an inch thread, again measuring across the flaps. If you were to measure 7/8, about 867 thou approximately. Yep, or in millimeters, very close to 22 millimeters. Okay, again threads per inch. 14 threads per inch, let's just double check. 14 threads per inch thread gauge. There you go, perfect match. Alright. So if you go to our website, you'll actually see these charts. So it'll actually assist you in identifying what you've got. Next size up, again most common size, is the 3/4 hose, which is 1/1/16. So again, measuring over the outside diameter of the thread. In millimeters, about 26.85 millimeters. In thousandths of an inch, it's 1 inch and 56 thou. Again, they use the same taper, 37-degree taper. This is a 3/4 hose tail with an 1/1/16 JIC swivel nut, designed to fit onto 3/4 hose. Yeah, now this hose can also come in 1-wire. We don't use a lot of 1-wire unless there's a weight or space limitation. I find 1-wire to be non-economical, really. I think 2-wire is a much more durable product. It lasts a lot longer, takes wear and tear a lot better. and for literally a couple of dollars a metre more, if that, it's well worth it. So we try and, as much as possible, use 2-wire, again, unless there's a weight or a space limitation or a flexibility issue. So we've discussed our hose, we've discussed our crimp-on ferrules for our 2-wire hose, we've discussed our JIC female swivel hose tails, briefly mentioned our adapters. Now our adapters, for example, this little adapter here, it's a 7/16 JIC male adapter, 20 threads per inch, 7/16 across the tips of the threads. The other end is actually a 1/4 inch BSP thread. Now 1/4 inch BSP parallel thread, these also come in BSP taper thread. Parallel threads, for example, you would use them, for example, if you wanted to connect a hydraulic hose to a valve. I mean, for example, this 2-way valve. A lot of our valves in Australia come with BSP threads and manufactured with a BSP parallel thread, especially high pressure products. Right? This has got what's called an encapsulated seal, so it's actually a groove machined into the back of the shoulder of the adapter. A special O-ring has been put in there, and then when you actually screw it, the O-ring is compressed, and that's what actually prevents any leakage. So 1/4 inch valve, 1/4 inch adapter, 7/16 male JIC, designed for a 7/16 hose tail. And when it's crimped on, you have a high pressure hose connection to a high pressure valve. These valves are rated up to 500 bar. 500 bar is about 7,500 psi. So it's a good high pressure valve. Again, all available from our website to purchase, or they can come assembled if you order them. Moving up, 9/16 JIC male, designed to fit 9/16 hose tail, and this has a 3/8 BSP thread. Now 3/8 BSP thread, again, larger fittings, larger hose, larger flow. For example, what we have here is a inline pressure relief valve with 3/8 BSP parallel ports. So, for example, same design, encapsulated seal, designed to take a high pressure hydraulic hose. So normally the oil will flow through here, adjustable pressure. If the pressure in the line gets too great, it will relief and come out of here. And generally this will relief with another hydraulic hose back to tank. This protecting the circuit, the hoses, the valve, and whatever else is in the system. What we also have here, again with 3/8 BSP parallel ports, is a 6-port diverter valve, again with BSP 3/8 ports. So this diverter valve you can use two supplies, or an up and down supply, to either send to a cylinder on doing one function, or send it to a cylinder or a motor doing another function, literally by moving that valve handle through 90 degrees. So now come into here and either go in that direction, in and out, or move it there. It isolates this one, locks it in place, in and out this way. So this is a 6-port diverter valve. So you take one function, one control, and you can actually do two separate things with it. Very good if you're on an excavator and you want to operate a thumb and or then switch to an auger or other attachment. Same thing, 6-port diverter valve, 6-port diverter valve. This is 3/8 ports, this is half-inch ports, half-inch BSP thread, again encapsulated seal, 3/4 JIC designed for half-inch hose, small valve, bigger flows. So bigger machines, higher oil flows. All these valves are rated to 350 bar, so plenty of reserve for most machinery. Again, half-inch BSP ports, and the encapsulated seal prevents all oil leakage. Again, this is designed for a half-inch JIC hose fitting, designed to take a half-inch hose. Again, half-inch hose with a half-inch 2-wire shell. Again, this needs to be crimped down to withstand the operating pressures. What else uses half-inch? Half-inch is a very common size, found a lot on a lot of small to medium equipment. For example, this is one of our flat-face couplers, our own brand, manufactured for us. ENGMATTEC is the brand. The hose is ENGMATTEC. Again, very common coupler, half-inch BSP parallel port thread, half-inch BSP adapter, quick connect, now you've got a quick connect, virtually dry break. These couplers are designed to disconnect with a very, very small fraction of oil being spilled, less than 0.1 of a mil, 0.15 of a mil every time they're disconnected. Almost nothing. .58 we've already talked about. Again, 5/8 not so common, used on bobcats and JCBs. JCBs will have a BSP thread, so this might fit a pipe or a valve on a JCB. On a bobcat, this, which is a half-inch thread, also get them in a 5/8 thread, again quite uncommon, but on a bobcat, 5/8's are reasonably common, but they won't use a BSP thread, they'll use an UNO thread, which I'll talk in another video. Literally the same thread, but with an O-ring here. Similar to BSP, but slightly different on the sealing, on the final sealing face, but I'll talk about that in another video. The final product, again, a larger flat face coupler, again virtually dry break, but again, larger couplers, larger ports, larger flows, designed for bigger machines. 3/4 BSP thread, 3/4 BSP female ports, again encapsulated O-ring, and this is designed again for larger machines, larger flows. Hose fitting. You'd use this on, for example, large augers. Again, this needs to be crimped down to a certain diameter to withstand the working pressures of this hose. So, if you don't want to know what you've got, hop onto our website, Hydraulic.Online. Lots of charts in there with thread identification and thread diameters, even thread diameters for the internals of thread. So if you're not quite sure what you're looking at, you can measure the inside diameter of your females, measure the outside diameter of your males, count the number of threads. Thread pitch gauges are the best way to measure stuff. There are alternatives, but I don't believe they're very accurate. Yeah. Get yourself a thread pitch gauge. They're not very expensive. You save yourself a lot of grief. You will be able to identify things a lot easier and do it yourself and save yourself a ton of money. Hope this has helped. If you have any questions, drop us a comment. Contact details on the end of the video. Love to hear what your next project is and how we can help you. Thanks for watching, and we'll see you next time.